The solar system is a vast cosmic stage where planets, comets, asteroids, and dust move in a grand celestial dance. Yet among these familiar objects, there may also be visitors from beyond our sun, bodies that did not originate here. Some of these travelers may be more than ice and rock. They may represent something far more extraordinary, objects built, not born. This is the mystery that now grips the astronomical community. It centers on a new interstellar visitor, 3I Atlas. Detected by the vigilant eyes of our telescopes, this object has ignited a storm of questions and debate. Is it a natural wanderer, like the countless comets that have passed through our skies for millennia? Or could it be a relic or even a probe from an alien civilization quietly crossing the gulf between stars? To appreciate just how profound these questions are, let's step back and consider the history of interstellar objects. In 2017, the world was captivated by the discovery of one Oumuamua, the first known object to enter our solar system from interstellar space. Unlike any comet or asteroid previously observed, Oumuamua tumbled through the inner solar system, accelerating in a way that defied easy explanation. It had no visible tail, shedding no gas or dust as icy comets do. The Spitzer Space Telescope, one of the most sensitive instruments for detecting such signatures, saw nothing. And yet the object did not move solely under the influence of gravity. It was as if something was gently pushing it along. Astronomers struggled to fit Oumuamua into existing categories. Was it a comet that had lost its tail, or something else entirely? The lack of outgassing, the odd trajectory, and its unexpected acceleration led some to propose radical ideas. Among them was the hypothesis that perhaps Oumuamua was not a natural object at all, but an artificial probe, an artifact sent by an advanced civilization. Fast forward to the present, and the arrival of 3I Atlas has reignited these debates. What makes 3I Atlas so peculiar? According to recent data, this object, like Oumuamua, lacks the visible tail or spectral fingerprints of gas that typically mark a comet's passage. Observations from the Hubble Space Telescope have revealed something even stranger, a diffuse glow leading the object as it travels through space, but no cometary tail trailing behind it. This is a direct challenge to the conventional wisdom about how comets behave as they approach the sun. The technical details are fascinating. Normally, as a comet nears the sun, solar heat vaporizes ices in its nucleus, creating a glowing coma and a characteristic tail of gas and dust. But 3I Atlas shows none of these features. Instead, it exhibits reddening colors with no evidence for cometary activity. Its brightness and trajectory are anomalous, raising questions about what forces are acting upon it. Astronomers have a term for such puzzling objects: dark comets. These are bodies that, despite their trajectories and non-gravitational accelerations, show no signs of outgassing or a visible tail. But is this label accurate? As some experts have pointed out, calling a technological probe a dark comet is akin to calling an elephant a stripeless zebra. It's a way of categorizing the unknown using familiar language, even when the analogy may not quite fit. This tendency isn't new. There are other examples where astronomers have mistaken human-made objects for natural ones. On January 2nd, 2025, for instance, the Minor Planet Center announced the discovery of a new near-Earth asteroid. Within a day, that announcement was retracted. It was not a space rock, but the Tesla Roadster launched by SpaceX in 2018, following a well-known orbit. Similarly, the object known as 2020 SO was first thought to be an asteroid until spectral analysis revealed that it was, in fact, the upper stage of a rocket from NASA's Surveyor 2 mission in 1966. Only detailed observations and knowledge of our own technological history allowed astronomers to correctly identify these objects as artificial. But what if we encountered an interstellar probe from another civilization with no prior knowledge of its launch or purpose? Without obvious markers of technology, no radio signals, no recognizable shape, our instruments might simply catalog it as an asteroid or comet. This is the crux of the challenge, distinguishing between the natural and the artificial. When faced with the unknown, the implications are staggering. If an advanced alien civilization wanted to study our solar system, it wouldn't simply send a single probe to fly through and disappear. It would likely deploy a mothership, capable of releasing many mini-probes into stable orbits around the Sun. These probes, if they exist, would be incredibly difficult to detect. Even the most powerful telescopes on Earth and the James Webb Space Telescope would struggle to resolve objects the size of our largest spacecraft at such vast distances. A 10-meter probe at the distance of the Earth from the Sun would subtend an angle of just 10 micro-arcseconds, far below the resolving power of any current technology, even the Event Horizon Telescope. And yet, these hypothetical probes might betray their presence through subtle clues. They could exhibit non-gravitational accelerations, motions that can't be explained by gravity alone without the usual cometary activity. This is precisely what astronomers have observed in objects like Oumuamua and now 3I Atlas. So, how do we proceed in this era of cosmic ambiguity? How do we ensure that when the next mysterious object arrives, we are ready to recognize it for what it might truly be? The answer lies in gathering more data, using more sophisticated observation techniques, and keeping an open mind to possibilities that challenge our assumptions. That's exactly what leading astronomers are now doing. The Galileo project, for example, is building a network of observatories capable of monitoring the sky across multiple wavelengths: infrared, visible, radio, and even audio. These observatories will scan for outliers, objects that don't fit established patterns, and analyze their properties using advanced artificial intelligence. And as 3I Atlas approaches its closest point to the Sun, the astronomical community is mobilizing to study it in unprecedented detail. Will it behave like a typical comet, erupting into activity as it heats up, or will it remain enigmatic, its true nature hidden just beyond the reach of our instruments? Even as the world's telescopes pivot toward 3I Atlas, the fundamental question remains: what exactly are we seeing? Recent Hubble images show a diffuse, sun-facing glow ahead of the object, yet there's no sign of a classic cometary tail or the spectral fingerprints of gas. The familiar hallmarks that help astronomers classify comets, their sparkling vaporous trails, are simply absent. This lack of visible outgassing, combined with the object's reddish hue and unusual trajectory, has set the astronomical community abuzz. Is 3I Atlas a new type of dark comet, or could we be witnessing something that defies all natural explanation? Some researchers propose that 3I Atlas could be an interstellar comet with unfamiliar properties, its material so dark or volatile poor that it resists the typical cometary display. Others, however, entertain a more radical possibility. What if 3I Atlas is not a comet at all, but rather an artifact of alien technology? This isn't as far-fetched as it might sound. History has taught us that objects with strange motions and no clear cometary activity often turn out to be technological debris from Earth. Take the case of the so-called asteroid 2020 SO, which was initially catalogued as a natural object. Only after careful study did astronomers realize it was in fact the upper stage of a 1960s NASA rocket, its non-gravitational acceleration caused by solar radiation pressure acting on its hollow metallic body. This lesson has profound implications for how we interpret interstellar visitors. In 2017, the first known interstellar object, 1I/Oumuamua, zipped through the solar system, exhibiting a trajectory and acceleration that baffled observers. No dust, no gas, no tail, just a tumbling, cigar-shaped object moving faster than any comet or asteroid ever seen. Despite the lack of evidence for cometary material, mainstream interpretations clung to the idea that Oumuamua was a rare, exotic comet. Yet, as with 3I Atlas, the data simply didn't fit the textbook definition. The debate over terminology, Whether to call such objects dark comets or suspect something more is more than academic. If an alien civilization wanted to observe the inner solar system, it would likely send a mothership with smaller probes, deploying them into stable orbits around the sun. These mini-probes, moving under their own power or propelled by solar radiation, could easily masquerade as natural objects, especially if they're small enough to evade detection by even our most powerful telescopes. Our current best technology, like the Event Horizon Telescope, can't resolve something the size of a spacecraft at astronomical distances. If these probes exist, they could be slipping through our observational nets, cataloged as comets or asteroids, simply because we lack the context or evidence to call them anything else. A fascinating parallel emerges from the recent discovery of so-called dark comets near Earth. A 2024 study identified two distinct populations of 14 objects each, all displaying non-gravitational accelerations, but no evidence of typical cometary activity. The term dark comet may simply be a placeholder, a catch-all for objects that don't fit into any established category. As the saying goes, an alien probe by the name of a dark comet would appear as intriguing. The history of science is filled with examples of mistaken identity, where technology masqueraded as nature or vice versa, until new evidence forced a re-evaluation. This uncertainty is why robust, multi-instrument observations are so critical. The Galileo project, led by Avi Loeb, is deploying a network of advanced observatories across the United States, scanning the skies in infrared, visible, radio, and even audio bands. These instruments will use cutting-edge artificial intelligence to sift through millions of detections per year, searching for outliers that defy conventional explanation. The goal isn't just to find more dark comets, but to rigorously test every anomaly, whether it's an interstellar visitor or an unidentified object closer to home, sometimes classified as a UAP or unidentified anomalous phenomenon. As 3i Atlas races toward its closest approach in late October 2025, the world will be watching. Will it erupt in a burst of activity like 2I/Borisov, confirming its cometary nature, or will it remain eerily silent, an enigma gliding past the sun, challenging our understanding of what truly populates our solar neighborhood? The research teams of the Galileo project and other observatories are poised to capture every moment, every data point, in the hope of finally answering the question, are we alone, or are these interstellar visitors messengers from another civilization? Whatever we discover about 3i Atlas, one thing is already clear: our ability to study and interpret objects from beyond the solar system is advancing at an unprecedented pace. Each new observation, each anomalous detection, brings us closer to understanding our place in the cosmos. The universe is vast, mysterious, and full of surprises. By keeping our minds open and our instruments ready, we give ourselves the best chance of recognizing the extraordinary, should it pass through our celestial backyard. Thank you for joining us on this cosmic journey. If you enjoyed exploring the mysteries of interstellar objects and the search for alien technology, make sure to like this video and subscribe for more content like this. The universe is waiting, and the next great discovery could be just around the